Kami ucapkan selamat datang, welcome kepada Mr. Erkan Coach sudah hadir. Oke. Ibu Anita, dapat mendengar suara saya, Ibu Anita?
Siap, dapat Pak.
Oke. Baik.
Gimana? Bisa saya lanjutkan atau gimana?
Sebentar, Bu.
Siap.
Bismillahirrahmanirrahim. Membuat pempek, jangan lupakan ikan, campuran sagu menambah serasi. Selamat datang hadirin sekalian, kembali lagi dalam seminar ini. Assalamualaikum warahmatullahi wabarakatuh. Yang kami hormati Rektor UIN Raden Fatah Palembang, Ibu Profesor Dr. Nyayu Khadijah, SAGMA. Yang kami hormati Wakil Rektor 1, 2, dan 3. Yang kami hormati Bapak Dekan Fakultas Sains dan Teknologi, Bapak Dr. Munir MAG. Yang kami hormati Wakil Dekan 1, 2, dan 3. UIN Raden Fatah Fakultas Saintek, UIN Raden Fatah Palembang. Dan wabil khusus kami hormati narasumber kita, Mr. Associate Professor Dr. Erkan Koç, Fakultas Mühendislik Universitas Karabük, Turki. Welcome, Mr. Yang kami hormati para Kaprodi Kabak Kasub di lingkungan UIN Raden Fatah Palembang. Yang kami hormati juga Ibu Anita Restu Puji Raharjang, MSI Embiomed SC, dan segenap panitia, para peserta dan hadirin yang berbahagia. Puji syukur, marilah kita panjatkan kehadirat Allah Subhanahu wa Ta'ala yang senantiasa memberikan nikmat, kesempatan dan kesehatan kepada kita, sehingga masih dalam keadaan berkumpul dalam majelis ilmu yang pada siang hari ini akan kita laksanakan. Salawat dan salam senantiasa kita haturkan kepada Nabi besar Muhammad sallallahu alaihi wasallam. Semoga dapat memberikan syafaatnya kepada kita pada hari kiamat nanti. Amin ya rabbal alamin. Baik, Bapak Ibu hadirin sekalian, pada hari sebelumnya telah kita sama-sama laksanakan dan kita sama-sama ikuti presentasi dua narasumber kita. Nah, pada siang hari ini telah hadir di depan kita ini di forum virtual kita seseorang yang spesial. Semoga yaitu Mr. Associate Professor Dr. Erkan Koç yang akan mempresentasikan dengan didampingi oleh Ibu Anita Restu Puji Raharjang. Nah, untuk itu kami persilakan untuk Ibu untuk melaksanakan tugasnya, Ibu, siang hari ini. Apa betul, Bu?
Ya, terima kasih Pak Hafiz. Alhamdulillahirrahmanirrahim. Saya senang sekali bisa berkumpul di tengah-tengah keluarga besar Fakultas Saintek UIN Raden Fatah Palembang lagi. Saya senang sekali, saya kangen. Dan saya senang sekali bahwa kegiatan kita hari ini sejak kemarin berjalan dengan lancar. Tanpa memperpanjang waktu, kami persilahkan kepada Associate Professor Dr. Erkan Koç. Time is yours. Erkan, could you hear me?
Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Can you hear me?
Waalaikumsalam warahmatullahi wabarakatuh. Yeah, your sound is clear. Go ahead.
Yes, dear Miss Rector of UIN Raden Fatah Palembang, Professor Dr. Nyayu Khadijah, dear Mr. Dean of Science and Technology Faculty, Dr. Munir, dear all the lecturers, staff, students, and all participants of the National Seminar of Science and Technology Faculty 2020. Assalamu alaikum wa rahmatullahi wa barakatuh. I want to say thank you for your invitation to join this wonderful occasion to be one of the keynote speakers. Before I continue my speech, let me introduce me and my institution. My name is Associate Professor Dr. Erkan Koç. I am a senior lecturer from Karabük University, Faculty of Engineering, Biomedical Engineering Department. My expertise is in biomaterials, especially biodegradable metallic materials such as magnesium alloys. Before I start my lecture, I hope that this meeting is not the first and the last. I wish we could meet again at another academic moment and doing some research collaboration together. The most successful person is not the one with many knowledge, but the one who could share their experience with others like you. Thank you. Wassalamu alaikum wa rahmatullahi wa barakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
I want to say in Indonesian language something. Terima kasih banyak telah mengundang saya ke pertemuan yang luar biasa ini di universitas. Saya menyapa dan menghormati semua orang. Like this.
That's awesome. That's wonderful. Thank you. Apa perlu saya translate? Oke.
Sorry?
Apa perlu saya translate, Bapak Ibu? Sepertinya yang disampaikan Pak Erkan tadi cukup jelas, Bapak. Beliau memperkenalkan dirinya. Jadi, so Erkan, you may continue.
Okay. I want to share my screen. Sorry. I'm trying to share my screen. Can you see?
Not yet.
Yes, sir.
Right. Yes.
First of all, I want to show you a short video with my university about my university.
Okay, go on. There's no sound.
No sound.
Nope. Make it louder.
I don't know how to make sound. Sorry.
You're right. You're right. Just continue.
Just the music here, not any speaking. Don't worry. Just music. You can read this information.
Pohon panas, ada pohon. Ada yang satu ayu. Untuk film bisu. Bilang aku perlu suara. Lagi yuk, aku kan bisa disetrum. Dari kabel rusak udah galak Pak, Pak. Dari kabel rusak dia sih udah galak.
Okay, probably you can explain to us your university because we cannot hear anything from your video, please.
Of course, I will share my presentation about university.
So while your video is appearing, probably you can explain something like our university have this faculty and whatever, so that
Yes, of
we
course,
can have
of course.
some information from that.
Just a second.
Someone is texting me and they say that your university, we wish that we can come to your university next.
Of course, you are also always welcome. We always invite you.
Thank you.
Can you see my presentation?
That's awesome. Continue.
Here is Karabük University in Turkey. We have in the Black Sea region in the north side of the Turkey. We have a small city, but our university is so big. My content of my presentation is first of all great history. UNIKA means University of Karabük. University of Karabük, UNIKA. Great team UNIKA, great learning UNIKA, great achievements and great global UNIKA. And my university was founded in 2007. We had first of all 4,685 students first of all, and then in 2019 we have now 51,000, nearly 52,000 students, and also international students. We have 8,000 students from different countries. In 2017, when UNIKA was founded, it had 4 faculties, 1 vocational school, 2 colleges. But now we have 15 faculties, 4 colleges, and 8 vocational schools, 2 institutes. And we also 1,028 academic staff, and most of them is doctor, and the professor is 14%, associate professor nearly 13%, and research assistant 30%. Administrative staff, support staff we have.
Langan njuk senadin Spanyol ya, jak senjin ngantar.
And we have we have 52,000 students, you know, and 30% in engineering faculty, and 33% social sciences, and 5% health sciences, and vocational school colleagues, nearly 30%. UNICA is the first public university also accredited by EAQLS, means the European Association for Quality Language Services, with its school foreign language in Turkey. We have good library, and we have a journal. We have published books 90,000 published books, and 131 journals in the library. And the GESTEC, Engineering, Science and Technology, an international journal we have in Karabük University. Science Station Index expanded. We have also UNICA Iron and Steel Institute. It is unique and only in Turkey, just one Iron and Steel Institute. It has dynamic test laboratory, residual stress measurement laboratory, elemental analysis, SEM, scanning electron microscope lab, static test laboratory, XRD, XRF, micro macro measurement, and all some of them, most of them are accredited. Meteorography laboratory, energy and environment, DTA, DSC laboratory, heat treatment laboratory, and our industries involvement. From 90 countries, we have 8,050 international students. The map here shows countries with more than 10 students. In Indonesia, you know, 13 students, and Palestine, Ethiopia, Somalia, Djibouti, Syria, Yemen, Iraq, Iran, Saudi Arabia, so many countries we have students here. UNICA also has more than 250 bilateral agreements worldwide. Here is our bilateral agreements. Universitas Indonesia. And UNICA produces its own electrical energy by the solar panels that are placed on the roofs and side walls. Here you see on the roofs and the side walls, we have solar panels. We produce our electricity. The solar panels are placed on 10,000 meters square, and they produce the 50% need of electricity that is used in our university, and in summer it is 70%. And we have corporate social responsibility always as well, social responsibility, and our from UNICA students to TÜBİTAK competition, great achievements here. UNICA was ranked 91st in the list of the top 500 service exporters in Turkey. And you see here agreements with partner universities, our rector, Professor Dr. Refik Polat. Agreements with partner universities. I don't want to take your time speaking with my university because we have short time, you know, one hour maybe. I can pass here. I participated in international fairs. Thank you for listening. My university presentation is short, you know, not details. I want to share my study as well. You see my presentation again?
Yeah, it's good.
Okay, my presentation is about an investigation of biocompatible AZ series magnesium alloys. I'm studying in biomedical engineering department, engineering faculty. But before that, I was studying in metallurgical materials department. After I get my promotion to associate professor, I passed to biomedical engineering department. My presentation contents are introduction, objective, experimental studies, results, and discussion. You know, here magnesium elements, magnesium metal has lighter, is lighter than the aluminum and iron. Its elongation is excellent compared to aluminum and zinc, and its weight is very light compared to aluminum and zinc. And its life cycle of the mold, excellent, not excellent compared to zinc, but good. Shock absorbing is excellent, magnesium. You know, biomaterials are divided by classified to metals, ceramics, polymers, and polymers composite. Metals is classified into especially biometallic materials, stainless steel, titanium, cobalt, chromium, and magnesium. You know, biomaterials are used in numerous medical applications today, such as fixation devices, replacements, and surgical equipment. Currently, implants are typical examples of a biomaterial application, and there are several different implant materials are used. You know, ceramic materials are known for their high strength and are generally biocompatible. The biggest disadvantage of ceramics is what? High brittleness. There are numerous polymeric materials used today, such as polyethylene, polyvinyl chloride. However, all polymers have the disadvantage of low strength, which eliminates their possibility to be used in load-bearing applications such as bone fixation devices. Due to higher tensile strength and closer Young's modulus to bone, metals are the most suitable biomaterial for load bearing of implant applications. Owing to high strength and good corrosion resistance, metallic materials such as constitute an important class materials in hard tissue implants, especially in load-bearing applications as bone screws, artificial joints, so on. However, these biometallic materials have many limitations. For instance, it's too stiff. They are too stiff. It means elastic modulus of these materials are much higher than that of natural bone. The serious mismatch in the elastic modulus will result in serious stress shielding effects, leading to reduced new bone growth, stress shielding effect. And moreover, they need to be removed after healing. It's extra cost to the health service. It increased patient trauma and morbidity. That's why we need some degradable biomaterials. Magnesium alloys as a new kind of degradable biomaterials. Magnesium is a lightweight metal with a density of, you see here, 1.74 grams centimeter cube density, which is 1.6 and 4.5 times less than aluminum and steel, respectively. And it has, you see here, it has an elastic modulus of about 44 gigapascal. This is low compared to other metals used as implant materials. A high, as I said before, a high mismatch in elastic modulus in biomaterials can lead to stress shielding, which is a common problem with bone implants. The formation of bone tissue is regulated by the load. If a material with higher mechanical properties is shielding the bone, removing all the stress acting on it, this may lead to bone atrophy. Magnesium also has compressive yield strength and fracture toughness closer to that of bone than other materials, including ceramics, polymers used as implants. Magnesium also biocompatible. It's important, biocompatible and biodegradable. Magnesium is fully bioresorbable. However, the poor magnesium degrades too quickly. Magnesium have disadvantages, have some drawbacks. Degrades too quickly in physiological systems with the pH level between 7.4 to 7.6 and high chloride concentration. Then the implant will lose its mechanical integrity because of fast corrosion. It will lose its mechanical integrity before the tissues sufficiently heal and the host tissue cannot deal with too much generated from corrosion process as shown here. Sorry. Also, magnesium is known to corrode in an electrochemical reaction. You see here, electrochemical reaction, which produces magnesium hydroxide and hydrogen. Here, hydroxide and hydrogen. Within the human body, magnesium degrades according to the reactions at cathodic reaction, leaving hydrogen gas bubbles and magnesium hydroxide. These hydrogen bubbles may cause physical problems such as blocking the bloodstream. Okay, these hydrogen bubbles may cause physical problems such as blocking your bloodstream. If the hydrogen bubbles are formed slowly enough, they will have time to diffuse into the tissue. So you cannot use pure magnesium. What solutions to reduce corrosion rate? This limitation, nevertheless, this limitation can improve by two methods: alloying and protective coating. We have to find new alloys. You know, as I said before, pure magnesium is light and fragile. Hence, magnesium is used by alloying with other metals such as aluminium, zinc, and manganese. And also magnesium rare earth alloys. For example, cerium,
Pak Muhammad Isna ini nih, Bu. Bukan. Yang satunya Mardia kan kemarin ya. Jadi semalam saya ditelepon oleh Bu Mardia.
Neodymium and praseodymium. AZ series magnesium alloys, AZ31, AZ61, AZ91, etc. And you need to also use coatings to reduce corrosion rate. You know, corrosion rate is a big problem in the human body. Calcium phosphate through alkali heat treatment, magnesium apatite, are both shown to reduce the dissolution rate of magnesium in simulated body fluid. What's the effect of alloying elements on corrosion behavior? Aluminium modifies mechanical properties, enhances corrosion resistance, and zinc increases the strength. Zinc can weaken the disadvantageous effect of iron. Zinc is a necessary microelement and component of many proteins, nucleic acid synthesis of human body. Manganese, since pick up iron, it can be used to control the corrosion of magnesium alloys. Manganese can also refine grain size, you know. And AZ91 alloy. AZ means, what's AZ means, my friends? AZ aluminium, AZ zinc, 9 means 9% aluminium, 1 means 1% zinc. AZ91 and rest of magnesium. Alloy has much better corrosion resistance than conventional aluminium alloys. AZ series alloys are used in automobiles, aviation, computers, and mobile phones. AM series alloys are used especially in the construction of steering wheel, car seat frame, in terms of high toughness and energy absorption characteristics. You can see here, if you use magnesium in your car, you can save your weight up to 70% lighter. But the main problem, is it easy to you to get magnesium? Not easy. The main problem with the use of magnesium alloys is the casting problem resulting from oxidation. Here, if you use without using shield gas, and magnesium oxidize easily, and loss of combustion, and therefore effective casting and high manufacturing cost. If you use shielding gas, you can see here a clean metal. Shielding gas, SF6 gas, sulfur hexafluoride. The focus of recent studies in the context of prevention of burning and oxidation loss in magnesium casting is the atmospheric controlled melting designs. What's my objective? My objective is to develop a model which may yield predictable degradation ratio versus strength as a function of aluminum and or zinc content of implant material in simulated body fluid. I used aluminum and zinc in my castings, in my experiments, and 0.5 zinc, 1 weight % zinc, 2 weight % zinc, 3 weight % zinc, and same for aluminum. And you can use 20 kind of alloys here, okay? And our production of alloy experimental procedure, our furnace, you see here, graphite, crucible. In order to produce that alloys, an electric furnace, which is completely atmosphere control. You know, as I said before, you know, magnesium alloys oxidize easily. So you have to use controlled atmosphere furnace, okay? The alloy was prepared by melting pure magnesium together with aluminum alloying additions in a graphite crucible under argon gas atmosphere at 750 degrees Celsius. After about 30 minutes holding and stirring, here you use ceramic pipe, holding and stirring, the melt was cast into a cast iron mold, preheated to 250 degrees Celsius, having some diameters and some length under protective gas. But we have to add zinc element 1 minute before the casting, because avoid loss of zinc due to vaporization. You know, zinc melting temperature is lower, is about 419 degrees Celsius. Our melting temperature here is 750 degrees Celsius. That's why if we use zinc beginning of the melting, zinc vaporization, so that we have to use 1 minute before before casting. Okay, and our mold is here, 20 millimeter diameter and 200 millimeter length. And sample preparation, we used the sample were grinded with silicon carbide papers from 120 to 2,500 grit, and later polished with alumina powder paste and washed with distilled water and ultrasonically clean in acetone for 5 minutes. And here is simulated body fluid. The in vitro corrosion studies were carried out in simulated body fluid maintained at a temperature 37 degrees Celsius and pH 7.4 as a simulated body fluid. The composition is composition of SPF is shown here. The solution was buffered by tris hydroxymethyl aminomethane. A typical 3 electrode system consisting of graphite here as a counter electrode, silver chloride or calomel electrode as a reference electrode, and sample Here is sample. Experiments. Potential dynamic electrochemical corrosion test, always circulating. You know, our body always circulating with some fluids, so that we have to use circulating flows in the experiments. You know, here and all pumping here and then always circulating. A schematic tensile samples used is being shown here for immersion of tensile samples to avoid corrosion attack. And we made some avoid corrosion attack here. We insulated these areas, and the white areas not insulated. It's exposed to simulated body fluid, and then we make it tensile testing to see the mechanical strength. Okay. And then samples were immersed here into SPF simulated body fluid in a beaker and kept in a incubator which is provide 37 degrees Celsius, nearly 37 degrees Celsius. Test durations is 1 day, 1 week. Test is holding here. pH values also measured periodically, because we have to make it 7.4 pH. Our results and discussion: alloys containing 0 aluminum. It means magnesium and plus zinc. It AZ 005 means 0 aluminum, 0.5% weight percent zinc, and rest of magnesium, and 1% weight percent zinc, 2 weight percent zinc, 3 weight percent zinc. And experiments show that as the amount of zinc element increases, you know, here is increases zinc, the particle size, you know, grain size of the magnesium decreases. It's a big grain, and when you add zinc, the grain is in expression. If you add 0.5 weight percent aluminum, aluminum addition dissolved as a solid solution in the microstructure, the grain size decreased again with the increase in the amount of zinc. See clearly microstructure, and it's interesting to in the 3 weight percent aluminum, adding 3 weight percent aluminum. If you add aluminum and zinc 3%, you can see easily intermetallic particles here. It affects corrosion, of course. You can see here in SEM microstructure, magnesium 17, aluminum 12, intermetallic phase. Also, the another one intermetallic phase. And the hardness test in magnesium zinc alloys, the increase in hardness increases linearly with the increase of zinc amount. Zinc can dissolve up to 2% in magnesium. So the linear hardness increase here is expected to occur from solid melt hardening. When the amount of aluminum reaches 3 a remarkable increase in hardness is observed because of, I said here, because of the intermetallic phases. Intermetallic phases is affected hardness. As seen here, and tensile strength, yield strength, and elongation. The tensile strength increases linearly again as the amount of zinc increases for each alloy. The yield strength of the alloys is quite parallel to their tensile strength, and elongations, unlike the yield and strength, tensile strength, as the aluminium and zinc amounts increase, a linear decrease occurs. This is caused by the increase of intermetallics. You know, in the microstructure, the increase in crack formation points and the increase in, okay? And here is, polarization test, electrochemical polarization test. When you see 0.5 zinc, increasing zinc in magnesium alloys, make it, you see macrophotos, decreasing corrosion rate, okay? When the macro pictures obtained from the polarization curves are examined, here you can see I have 20 kinds of aluminium alloys. Sorry, it was observed that pits, here you can see pits on the surface decreased with the increase of both aluminium. Here is aluminium is increasing. Here horizontal side is zinc is increasing. The pits on the surface decreased with the increases of both aluminium and zinc. A striking point is here is that when looking at alloys containing 3% zinc, pits increase in alloys containing 0.5% and 1.1% aluminium. And here is some images after 1 day immersion test. Some images after 1 day immersion test. As can be understood from the SEM images, it's seen that corrosion progresses from the surface to the interior. From the surface to the interior. This progress accelerates with the increase of zinc and aluminium amounts. It should be noted that the intensity of aluminium in corrosion progression is much more effective than zinc. On the other hand, here you can see some images after 1 week immersion test. On the other hand, it's seen that 7 day, 1 week corrosion in the cross section of alloys containing high aluminium progresses much more in length. In alloys containing aluminium, as I said before, vertical side increasing aluminium, horizontal side increasing zinc. Just 0.5 zinc and 3 zinc, I put it. Corrosion progresses towards the interior through the intermetallic phase. You see here what made intermetallic phase? Very bad corrosion progress. because intermetallic phase is accumulates in the grain boundary, and it's make it weaken the alloys. And you can see here, it's clear here from these tables that the surface damage that occurs in corrosion increases dramatically with the increase of both the zinc ratio and the aluminum ratio. After 1 day immersion test, after 1 week immersion test, you can see here, if you use 3 aluminum, 3 weight% aluminum and 3 weight% zinc, you can lose your samples after 1 week. It means you cannot use 3 weight% aluminum and 3 weight% zinc with magnesium in the body long after 1 week. Okay. Mechanical test results after 1 day immersion test and after 1 week immersion test, and results microstructure of if your zinc increases, then the amount of zinc increases, grain size is decreases. And if you use 3 weight% aluminum and the intermetallic phases is occurring and decreases the mechanical strength, aluminum and zinc increases hardness, tensile yield strength and increase, but elongation is decreased. Polarization test. For the polarization test, for 0 aluminum, if when the zinc increases, corrosion resistance increased. But if you use 0.51 and 2 weight% zinc, aluminum increased, corrosion resistance increased. But the alloying elements getting increased, for example, 3 weight% zinc and 0.5 and 1 aluminum corrosion resistance decreased, but 2 aluminum increased, 3 aluminum decreased because of the intermetallic phases. Thanks for your attention. Thanks for listening me. It's okay now. Finish my presentation.
Thank you so much. Oke, silahkan Bapak Ibu dan partisipan yang ingin bertanya bisa langsung menuliskan pada kolom chat atau ya terima kasih atau direct message ke saya boleh atau langsung everyone aja, jadi biar semua orang juga bisa melihat apa pertanyaannya. Oke, before everyone has the question, I have one question for you, Dr. Erkan.
Okay.
Because now our institution is developing new laboratory. So if Faculty Sains and Teknologi UIN Raden Fatah Palembang really want to have to do the same research as you, so what kind of tools that we need to prepare to do the same? Thank you.
To the same experiment, you see, you mean?
Same experiment like you, so that probably we can really do collaboration research because we have probably the same.
Of course, I can really do and make some collaboration with you, of course. Why not?
Yeah. Because we are now developing our new laboratory. So what kind of tools that we need to prepare to do the same research as you do?
Of course, if you invite me, I can happily to come there to join us.
No. My question is, what kind of tools we need to prepare? Because we will buy probably. Right now we have already the SAM. We have the SAM, but what kind what any other tools that we need to prepare?
Electrochemical corrosion test equipments
Yeah.
you need to,
Okay.
and optical microstructure. But it's actually it's easy to make it experiments, not too hard. As I can
Because right
share.
now we have our dean with us, but Dr. Munir is with us, so probably our dean will help us and support us to buy new tools. So this is our opportunity to ask to buy the new one.
Of course, I can write you the list of the experiment tools. Now,
Please, thank you.
exciting. I forgot some explanation in English. I can write the list of the experimental tools.
Okay. Okay, hang on. I think there is one question from Ibu Mariama. She's asking, what's the example of application for this material? What is the example of the application for this material? You can read it on the chat.
Yes, yes, and some screws in the body.
The Zoom chat, everybody can read it. So, Bu Mariama is from mechanical, I think, from mechanical engineering, and she's asking about what the example of application for the material that you use.
Some screws in the bone for combining the bone. Some you can make some stents in the heart valve for the blood flooding, stents and some screws. Okay.
Okay, Bu Mariama, are you okay with that answer, or you want to say something? Bu Mariama, please do. Bu Mariama, monggo, silakan.
Because it's it's degradable. You cannot use many years as an implant. Okay, just 2 weeks, 4 weeks. After healing, it's degrades from your body, just for screws.
All right. Okay, so that could be different with the platina. For some people with a broken bone, so it's different because the platina we have to remove it, but your material is
extra
quite
cost,
different.
extra more in this immorality.
Yes, yeah, please, Bu Mariama, please.
Okay, sir. Thank you for your time. You say it can be used to solar sunscreen, ya tadi. Is it?
Just some stands. Just for 1 week, 2 weeks, or 2 months, 3 months healing. After healing, because of it's degrades. Not many years. Just combining the after healing bone, combining your bone, and then degrades. For example, that's why it's used some screws, stands, something like that.
All right, Erkan, would you please to show us the title of your presentation? Please do share screen and show us your title of your presentation for today. Okay, Erkan, please, Erkan in Pak Erkan, Pak Associate Professor Dr. Erkan itu, ya. I'm talking in my friend in bahasa Indonesia. I said, okay, well, you prepared it, right? Cool.
Okay.
Ya, Bapak Ibu, Pak Erkan itu mengerjakan penelitian. Kalau biasanya kalau kita tulangnya patah, kan kita dikasih pen ya. Nah, pen yang berbeda yang disampaikan oleh Pak Erkan ini, dia akan menempel di tubuh kita dan dia akan hilang begitu saja. Ketika sudah sekian tahun, maka tidak perlu diangkat lagi pennya gitu. Jadi kayak semacam pen yang biodegradable seperti itu. Jadi ini menarik sekali. Oke, Erkan, can you do share screen because we want to see your title?
Yes, I'm sharing now.
No, I cannot see it.
Really?
All right, it's still working probably, yeah.
Sorry. Resume. It's now okay?
Yeah, it's good. Ya, ini adalah title dari Pak Erkan, an investigation of biocompatible AZ series of magnesium alloy. Nah, jadi ini bisa digunakan sebagai pengganti pen untuk dimasukkan dalam tubuh, misalnya seperti
Dia tuh
yeah, you can talk to Pak Erkan by yourself, Bu Rodia. Go ahead.
Okay, thank you very much for the time. Well, let me introduce myself. Hello, Professor Erkan. My name is Rodia. So here I'm so interesting with your research. My question is, it's you collaborate with chemists to do this research, or only you? I mean, only biomedical engineering? Or
No,
do you
just we collaborate chemistry, material science, biomedical science.
Oh, so all of that subjects that done this research, right? So, well, I'm a chemist, so if probably we can like collaborate or something, what can I do for this research? What part of this research that the chemistry can do for this regarding your topic?
Of course, maybe you can research. You can search the. For example, we are immersion test. We use immersion test. 1 day, 1 week, 2 weeks. After 2 weeks, for example, after 1 week, you can use the solution, and then you can examine what's before immersion, after immersion, what's the changing in the solution. FTIR, for example, testing, something like that. I don't know.
Oh, so that's the chemists do, and as a biomedical engineer, you design the the things. Is that how it works?
So I could understand. Can you tell me again?
Yeah.
Can you ask?
Yeah, I mean, maybe probably in the future we can collaborate between Karabuk University and Win Raden Fatah Palembang, because I'm a chemist. So what can I do regarding this research so we can collaborate? Maybe I can, what is my contribution as a chemist to do this research as you do?
You can research some literature, right? Because it's too far. You have to come here, or I can come there.
Yeah.
Just research.
Yeah, we can collaborate. Our what we call it, like apa ya? Yeah, like topic. I mean, we can sharing our topics, and we do here and you do there, and then we can collaborate to like write the paper or something. So maybe
Sure,
is that possible?
Okay, it's possible. Yes, it's possible. Yes, we can do something. Okay, we can write email.
Yeah,
we can do something. Okay, hopefully, I want to see Indonesia. I want to come there, but because of COVID-19, it's very hard situation for us. And you can also come to visit here. I've been, but 10,000 kilometers is not far, because I went to Australia
Oh yeah.
9 or 10 years ago. That's why that's what we can do, some collaboration. It's easy.
Yeah. Well, because
I'm close to you with the computer, okay, with the mails.
yeah. Yeah, because you say, or what you have done here, it's regarding magnesium alloys. That's what chemists done here. So maybe, yeah, we can collaborate whatever, like maybe another compound that we can make to be biocompatible. What is it? What is that? I don't know. So that's why I asked you. Maybe we can like make another discussion that's related to the results. Maybe, is it possible or something? Because
Yes,
yeah,
sure. But it's now paused. It's now stopped because of
yeah.
COVID-19. Maybe in the future, we can do something. If you find something in the literature, you can send it to me mail. We can do some collaboration. Why not?
Yeah. Okay. Well, thank you very much.
No worries. You are welcome.
All right, thank you so much. Okay, there are two more questions from the lecturer. Your presentation is really good, so everyone are really interesting with your topic. Okay, the first question is from Pak Awal. Pak Awal is biology lecturer. He is now already has the material, magnesium material combined with herbal medicine. And do you
Can I
think it's
see?
probably we can use magnesium? Sorry?
Can I see the?
No. Pak, hang on, Pak. Pak Awal silahkan ditaruh di everyone chat sehingga Pak Erkan bisa melihat. Please do, Pak Awal. Yeah, because
I'm not.
she's chat me on the direct message, so you cannot see it. But probably you can read the chat from Pak Irham. Pak Irham is the first vice dean. He's asking why it's not dangerous to use AZ as a long time because of any material.
But it's some of them are dangerous because of the aluminium gets the dementia. You can use some test hydrogen gas evolution, or if you use more than zinc, it's getting the damage again. This chemistry is you can, or biologists can measure the damages of, or some medicines can measure. I didn't measure the dangers of the AZ as a long time. Maybe next research we can.
Yes, a long time. It's long time. AZ for not dangerous our body.
2 weeks and 4 weeks. I made not just 1 day or 1 week. I made 2 weeks, 4 weeks tests, but it's getting broken. All the samples broken, and I don't know the dangers of the human body, but the mechanical integrity, mechanical strength is getting weakened, even broken in the bigger. So I couldn't use the 2 weeks, 4 weeks results.
Thank you, Mr. Erkan.
We can make it good with coating or changing some alloying elements, or we using heat treatment. something like that. Thank you very much.
Thank you.
Okay, please. All right, interesting. It's very interesting. Bagaimana Pak Irham? Ada yang ingin tanggapi?
Enough.
Any question?
Enough. Thank you. I think long times it's dangerous. They use pen and broke skeleton.
Okay, for everyone, I want to translate. Jadi, sorry, Bapak Ibu, saya ingin mentranslate apa yang disampaikan oleh Associate Professor Dr. Erkan yang saat ini sedang bersama kita, bahwa beliau menemukan sebuah cara. Jadi kalau misalnya kita tuh tulangnya patah, biasanya kan kita memasang pen. Nah itu dulu kan masih harus dibuka untuk kemudian diambil pennya. Nah sekarang pennya itu kalau berupa magnesium alloys itu tidak perlu diambil karena dia akan biocompatible atau nempel dan dia bisa biodegradable sehingga aman bagi tubuh kita. Seperti itu. Ada yang ingin menanggapi? Silakan. Kita masih punya beberapa menit sebelum kegiatan kita ditutup.
Ya, saya
Kami
Mbak
juga
Anita.
mempersilakan kepada Bapak Ibu untuk, ya silakan monggo Bapak.
Ya, makasih. Selamat datang Pak Erkan ya. Saya tadi nyoba nyari bahasa Turki dari translate Google itu. Jadi gini, menarik saya kira ya. Ini bagian dari integrasi ilmu yang sekarang kita sama-sama berkeyakinan ini bagian penting dari proses pengembangan Fakultas Saintek Winda dan Fatah Palembang. Jadi kalau saya simak tadi ini paling tidak ada gabungan, ada ilmu kimia, kemudian teknik, biologi dan kedokteran gitu ya, kedokteran. Jadi sudah gabungan. Dan intinya tadi adalah yang pertama bagaimana alat itu kemudian bisa hancur di dalam tubuh tanpa treatment lanjut. Yang kedua ini tidak menyatu tetapi hancur. Kemudian saya berpikir jangan-jangan ada semacam herbal yang mampu ikut mempercepat kira-kira gitu ya, mempercepat alat ini kemudian berubah materialnya berubah kemudian menjadi semacam cairan yang ramah dengan tubuh kita. Akhirnya begitu ya. Misalnya saya mengamati seperti kasus khitan itu ya. Kalau dulu pakai benang kemudian dilepas, kemudian ada benang catgut, ditemukan catgut, kemudian tanpa dilepas lagi menyatu dengan tubuh. Nah, jadi kira-kira pertanyaan untuk Pak Mr. Erkan ini, ada nggak, besar nggak kemungkinannya ada semacam tumbuhan atau herbal atau tumbuhan lokal wisdom yang bisa ikut mempercepat dalam proses larutnya material campuran aluminium sama zinc tadi ya. Ya, oke ya kira-kira gitu ya Mbak Anita, terima kasih.
Siap Pak Dekan, siap. Pak Dr. Erkan, are you there? Copy. Can you hear me?
Can you please translate?
Yeah, I will do that. All right. The one who is just speaking is our Dean, and he said that he really thank you that you are here with us today, and your presentation is very good. And he was thinking about circumcision. You know, circumcision. You got it, Arkan?
Yes.
Yeah. Previously, when we do circumcision, we have to. Well, I never do circumcision, so it's a bit. I don't know. I mean, previously people use. Pakai apa sih kalau sunat? Saya nggak ngerti. Gimana? Okay. Oh, pakai apa? Benang.
Benang silk.
Sorry?
Seal.
Bisa dibantu nggak? Saya nggak dengar, bisa atau di chat.
Okay.
So when previously when someone do circumcision, they I never know. Sorry. Okay, seal. Yeah, someone were using seal.
Seal.
Is it? And the seal. Yeah, you know, seal. I will write it for you. And the seal will be inside the body, and that will be okay because the seal is biodegradable. And do you think your material will do the same as the seal on circumcision? Please.
Seal means, coating, you mean? Coating.
It is clothing. Yeah. Seal.
Coating, of course, yeah,
Clothing.
protects corrosion.
So your
Yes.
material will do the same effect as seal. And
Of
how
course,
long?
and
How long the? Yeah.
I
Please.
don't know. Micro arc oxidation, maybe micro arc oxidation coating we can do. I will study with the coating about coating, just in the future researching. Okay. I don't have any good idea to tell you. Okay. But it's some research about coating.
All right, interesting. One more question from the Dean. Can we use material, your metal material, and we combine it with the herbal? What do you think?
Sorry, herbal?
A herbal is something like herbs or what is it?
Really, I don't know. Sorry. Herbal.
You have no idea with that? No? Oke, Pak Dekan, Pak Erkan belum mengetahui kalau seandainya bahan materialnya bisa dicampur dengan herbal. Pak Erkan belum mengetahui. I mean, herbal from plants. Do you have idea that we can combine the material from the herbal from plant? You don't know. No, oke. Pak Dekan, Pak Erkannya nggak tahu Pak, karena belum ada penelitian sih tentang combining, menggabungkan antara material logam dengan herbal untuk biodegradable material.
Yang saya tanya adalah kemungkinannya. Karena begini, misalnya kayak korosis ya, korosi karat. Karat itu kan selama ini misalnya diatasi dengan zat kimia. Ternyata ada zat dari herbal yang bisa menghilangkan karat dan menjaga besi itu tidak berkarat. Nah, itu ya. Maka saya kiaskan gitu ya, beranalogi seperti itu. Ada nggak arahnya itu nanti ke sana? Oke, thank you.
Erkan, the Dean asking, is it possible in the near future that probably we can make a solution to solve the corrosion from the herbal, from the plants material that probably will solve the problem of corrosion? What is your opinion? Is it possible?
Yeah, of course, it's possible. Yes, we can do some collaboration. Yeah, if you want, I can send you some samples, and you can make something with herbal or I don't know.
Okay,
awesome, thank you. Iya, bisa Pak Dekan, katanya Pak Erkan bisa.
I have so many casting samples.
Ya, ini maksudnya ini kan saya mencoba untuk tadi mengasosiasikan apa yang disampaikan oleh Ibu Rodiah juga gitu ya. Nah, jadi bagaimana kita melakukan kolaborasi tapi tidak harus satu tempat begitu kan? Artinya penelitian itu nanti membutuhkan banyak material dan beberapa langkah-langkah, tahapan-tahapan. Maka bentuk kolaborasinya nanti mungkin bisa berbagi gitu ya. Jadi siapa melakukan apa pada tahap apa, kemudian nanti didiskusikan gitu ya, didiskusikan. Kemudian sama-sama melakukan tapi tempat yang berbeda, hal yang berbeda, tetapi untuk membuktikan menemukan satu produk gitu ya, satu produk yang merupakan karya bersama dan bermanfaat untuk kehidupan. Saya kira begitu ya. Coba lah nanti. Terima kasih
Siapa Dekan? Siapa? Jadi Pak Erkan telah berkolaborasi dengan kami di UGM bahwa Pak Erkan tuh ngirimin logamnya dibawa ke sini. Kemudian di sini kami melakukan biotoxicity atau uji toxicity assay atau uji keracunan. Jadi kalau itu kan dimasukkan ke badan itu gimana fungsi racunnya gitu, apakah beracun apa enggak, itu di sini. Jadi saya yakin juga akan bisa dilakukan hal yang sama di UIN Palembang gitu. Jadi caranya seperti itu. Jadi Pak Erkan mengirimkan ke sini, nanti kita ngirimkan ke sana kayak gitu. Jadi kita bisa melakukan kolaborasinya seperti itu ke depannya.
Oke, ya, soon.
Begitu Pak Dekan. Right, thank you. So Pak Hafiz, kita punya berapa menit lagi? How many minutes we have? Because it seems like it's so interesting and everyone want to ask and talk to Pak Erkan. So how many minutes we still have, Pak Hafiz?
10 menit lagi, Bu. 10 menit
Please. All right, Erkan, we still have 10 minutes to go. And you know, like we have more than 10 questions for you. You can read it on the chat.
Yes.
And probably you can read it and answer it directly if you want. Cool.
How long will this material be biodegradable? How long? I use this 4 weeks, but in the literature, 6 weeks, 8 weeks is tried before. Is biodegradable screw and can stimulate the formation of new bones faster and does not cause marks on bone joints. I don't know. The biodegradable screw can stimulate the formation of new bones faster. Yes, this tool can be applied to humans, but of course, before the humans, in animals, we have to do try. But now I'm trying. I am just with my collaboration in the animals. I'm trying to do, but not get the good result. Not get results now. If I get some results, I will share with you again, or some papers you can see in the future. Yes, this tool can be applied to humans. How effective this? But of course, before the humans, in animals, we have to do try. But now I'm trying. I am just with my collaboration in the animals. I'm trying how effective it is.
Okay.
I don't understand the question of how effective these methods, because these methods function in patients. I just tried just metallurgical area in the mechanical hardness, corrosion resistance, but in the future is a good collaboration with the medical science. I didn't use it in vivo environment, just in vitro, in simulated body fluid, not in vivo. I'm not say I don't want to say any wrong things about in vivo, because I didn't try.
One more question.
Yeah. Question. Can this material? Günaydın, Farhan. Good morning, Farhan. Can this material production in big scale? Yes, we are using. If you have atmospheric controlled furnace, you can produce it. But after that, you can make it machine operation to make it stands, to make it screws. It's difficult, more difficult than the casting, than the producing materials. Producing is a little bit easy. To make it operation in the for making screws, for making any implant materials. But if you have good furnace in the casting, about casting, if you have some ladle, you can use it, you can make it good samples. Okay.
All right, I think that's the end because we've been through more than 1 hour. Thank you so much. Time is yours, Pak Hafiz.
I'm also thank you to invite me. Inshallah, next meetings we can do it again.
Yeah, still amal jariyah lillahi ta'ala.
Baik, terima kasih kepada Ibu Anita, mobil khusus Mr. Associate Professor Erkan Coach telah menyampaikan materinya, sekaligus sebagai narasumber kita pada hari ini, ya. Bapak Ibu hadirin sekalian, berikut ini penyerahan sertifikat secara langsung dan secara virtual maksud saya kepada narasumber. Kami awali mohon kepada kepada Dekan Sains dan Teknologi, kepada Pak Dekan, boleh semuanya Bu ya, jadi kepada Pak Dekan, kepada Bapak Dr. Munir Mage untuk menyerahkan sertifikat kepada narasumber yang pertama.
Itu ya. Jadi gimana teknisnya itu?
Thank you very much for the certificate.
Oke, thank you.
Ini nanti ini akan coba kita bahasa Inggris ya, Mister, mohon maaf belum kita buat dalam bahasa Inggris. Dr. Erkan Coach, kami persilakan Bapak Dr. Munir.
Halo ya, gimana?
Ya, kami mohon kepada Bapak Dr. Munir untuk menyerahkan penghargaan sertifikat kepada narasumber Mr. Erkan. Silakan.
Nggak terdengar ya? Saya ngasih sambutan di mana? Penutup?
Belum Pak, nanti ada sambutan, ada sesi.
Mohon direvisi, namanya kurang.
Ya.
Oh gitu.
Ya nanti direvisi, kayaknya kurang semangat.
Oh ya, siap nanti direvisi ya, siap. Ya.
Silakan Pak Dekan ngasihkan dulu. Nanti baru penutupan sambutan.
Ngasihnya gimana caranya, teknisnya?
Ya atas sambutan atas nama fakultas itu Pak, ucapan terima kasih.
Oh itu ya, baik. Ya, Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Salatu wassalamu ala Rasulillah wa la haula wa la quwata illa billah. Awalan syukran jazilan ala akhina Associate Professor Dr. Erkan Coach. Ahlan wa sahlan wa marhaban bi hudurikum fi hadhil jami'ah Windaden Fatah Palembang. Tasyakur in this seminar, ya. Tentu kami mengapresiasi atas kerjasamanya dan peluangnya. Tadi saya mengikuti apa yang disampaikan dan respon dari teman-teman para dosen tentang apa yang telah dilakukan oleh Mr. Erkan. Mudah-mudahan ini betul-betul bisa menginspirasi, membangkitkan gairah, dan perlu saya sampaikan Mr. Erkan, kami Fakultas Sains dan Teknologi Wilayah Fatah Palembang memang sedang menggalakkan dengan gerakan integrasi ilmu, integrasi sains, dan ini akan menuju integrasi sains dan Islam Melayu Nusantara. Jadi kalau ada pertanyaan hubungannya dengan herbal, lokal, dan seterusnya itu memang lagi masanya. Oleh karena itu tentu kami memberikan penghargaan yang setinggi-tingginya seterusnya kepada Mr. Erkan atas partisipasinya, dan mudah-mudahan tidak kapok ya. Lain waktu nanti akan kita undang lagi untuk bisa bergabung, dan sementara ini hanya bisa memberikan penghargaan berupa sertifikat. Mudah-mudahan nanti kalau sudah pasca pandemi kita akan mengundang secara langsung datang ke kampus kita, bermuajah, bersilaturahmi, dan melakukan kegiatan-kegiatan yang inspiratif dan bermanfaat bagi kita. Itu sekali lagi terima kasih. Ya, silakan Mbak Anita.
Yeah, thank you. Erkan, the Dean of Faculty of Science and Technology just mentioned that he really happy that you are here today, and he really wish to invite you to come to Indonesia next time. Amin.
Amin.
Amin. Inshallah. Inshallah. Amin. I also hope to come there.
Baik, terima kasih Mr. Erkan. Selanjutnya kami ucapkan juga kepada narasumber yang kedua, boleh ditampilkan host sertifikat atas nama Bapak Dr. Yahfizam MCS, dapat ditampilkan. Sebagai narasumber yang pertama, yaitu sebagai penghargaan dari Fakultas Sains dan Teknologi UIN Raden Fatah Palembang. Dan selanjutnya narasumber yang ketiga, Ibu Dr. Cut Mutiadin MSI, kami persilakan untuk ditampilkan. Ya, itu sertifikatnya. Baik. Bapak Ibu hadirin yang kami hormati, untuk selanjutnya penghargaan kepada peserta, kepada pemakalah yang terbaik. Di sini sudah kita dapatkan informasinya, dan juga kami minta kepada panitia untuk dapat menampilkan ya sertifikatnya atas nama. Yang pertama pada klaster program studi sistem informasi, itu jatuh pada Bapak Bayu Wijaya Putra, Bapak Rahmat Fadri Isnanto, dan Ibu Purwita Sari dengan judul deteksi aritmia pada sinyal EKG dengan deep neural network. Nah, selanjutnya pada klaster prodi kimia terpilih Bapak Roni Suprayitno, Ibu Damayanti Skandar, dan Ibu Fitria Wijayanti dengan judul pemanfaatan nikotin dari ekstrak tembakau sebagai insektisida hama Coptothermus ya, curvignatus. Silakan ditampilkan. Baik, terima kasih. Dan klaster program studi biologi terpilih Bapak M ya. Oke, ya agak terbalik tapi nggak apa-apa ya. Bismillah. Bapak Muhammad Jauzi, Ibu Retno Susilawati, dan Ibu Bayinatul Mukhtaromah dengan judul pengaruh suhu dan lama thawing terhadap viabilitas sperma sapi Madura. Baik, dapat ditampilkan kembali Bapak Jauzi. Oke, baik, terima kasih. Nah, tiba saatnya kita mendengarkan sekali lagi kepada Pak Dekan ya untuk memberikan beberapa kata sekaligus menutup acara seminar nasional. Kami persilakan kepada Bapak Dr. Munir MAG, waktunya. Kami persilakan Pak.
Ya, baik, terima kasih. Sekali lagi, Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, wassalamu ala rasulillah, wala hawla wala quwata illa billah. Puji syukur kita panjatkan kepada Allah Subhanahu wa taala. Alhamdulillah, apa yang kita rencanakan, apa yang kita niatkan dapat terlaksana dengan baik. Seminar ini sebenarnya seminarnya internasional. Seminar nasional rasa internasional, gitu ya. Sejak kemarin sampai hari ini berjalan dengan lancar, narasumber bisa hadir semua, partisipasinya cukup stabil, gitu ya. Ini terakhir masih di angka 130 lebih, dan itu memang salah satu hikmah dari pandemi COVID-19 gitu ya, karena menghadirkan 130 orang secara tatap muka, secara luring itu agak sulit. Nah, oleh karena itu patut kita syukuri, alhamdulillah kita sehat semua. Kemudian salam serta salam kita sampaikan kepada Rasul Muhammad SAW. Mudah-mudahan kita semua menjadi umatnya setia sampai akhir zaman, mendapatkan syafaatnya dan bisa menjalankan amanah risalah mengembangkan tradisi untuk kehidupan umat manusia yang lebih baik. Kemudian saya ucapkan banyak terima kasih kepada segenap panitia, para dosen, serta peserta yang telah setia, sabar mengikuti seminar ini dengan tertib, dengan disiplin, dan juga terima kasih kepada para narasumber, terkhusus narasumber kita dari Turki, Mr. Erkan Koç, ya, yang saya kira 1 jam sebelum waktunya presentasi itu sudah bergabung tadi, ya. Jadi sebuah kehormatan. Nah, kegiatan ini saya kira momentum yang tepat karena kita sedang menuju tahap kedua dari apa yang telah kita cita-citakan menjadi kampus yang berstandar internasional, berwawasan kebangsaan dan berkarakter Islami. Jadi momen-momen kegiatan-kegiatan yang sifatnya internasional itu sebuah tuntutan, ya, sebuah tuntutan. Mudah-mudahan tahun depan bisa lebih banyak lagi. Dan saya baca tadi banyak sekali peluang-peluang yang bisa kita lakukan dari beberapa makalah yang disampaikan oleh para narasumber. Tadi saya minta ringkasan Ibu dari WD1, ya, itu bagus-bagus semua. Ternyata banyak peluang yang bisa kita lakukan, termasuk terakhir tadi dengan Mr. Erkan yang telah bersedia untuk melakukan riset kolaboratif dengan kita. Mudah-mudahan ini juga bisa kita tindak lanjuti dan saling mengingatkan agar tahun 2021 itu pranatanya itu disiapkan, termasuk pendanaan gitu ya. Kita berasumsi sudah tidak pandemi, ya kita saling ingatkan, saling dukung. Mudah-mudahan itu bisa kita laksanakan, terutama tadi apa yang berkaitan dengan peradaban Islam Melayu Nusantara. Ya. Mungkin tadi seperti beliau menemukan alat, nanti mungkin bicaranya lebih apa didevelop lagi gitu ya, dikembangkan lagi bagaimana seandainya di Rekayasa seperti ini, seperti itu, kira-kira begitu. Dan itu juga semua tentu bermanfaat dan apa namanya sangat membantu untuk meningkatkan nilai akademik masing-masing universitas. Sekali itu, oleh karena itu saya memberikan apresiasi yang luar biasa kepada para wakil dekan, para kaprodi, sekretari prodi, para dosen dan segenap panitia yang telah melakukan lelah. Mudah-mudahan ini merupakan amal jariah jalur akademis ya yang sudah kita lakukan, dan insya Allah hasil terbaiknya akan kita petik pada saatnya nanti. Demikian, terima kasih sekali lagi dan mohon maaf. Mari kita tutup dengan bersama-sama membaca hamdalah. Alhamdulillahirabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Bapak Ibu hadirin yang kami hormati, satu lagi acara di sini kita tidak lengkap rasanya. Bagaimana cara kita mensyukuri? Maka kita hadirkan seseorang untuk memimpin doa pada kesempatan sore hari ini. Kami mohon kesediaan Bapak Andi Saputra, SKM Geomet. Kami persilakan.
Baik, Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum.
Bapak dan Ibu hadirin para sekalian, marilah kita tundukkan kepala sejenak, bermunajat kepada Allah. Semoga kita selalu dirodai olehnya dan semuanya yang kita lakukan tercatat sebagai pahala di sisinya. Amin ya rabbal alamin. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Hamdan syakirin, hamdan na'imin, hamdan yufi ni'mahu wa yukafi mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhikal karim wa 'azimi sultanik. Allahumma salli ala sayyidina Muhammad wa ala ali sayyidina Muhammad. Ya Allah, anugerahkan kami sebagian ilmu-Mu dan jadikanlah kami sebagai mengamalkannya untuk masyarakat, agama, bangsa, negara kami. Mudahkanlah kami dalam berkarya dan jadikanlah karya kami ikhlas hanya untuk-Mu. Catatlah setiap langkah dan gerak kami sebagai amal ibadah kami di sisi-Mu. Ya Allah, sebagai langkah kami mendekatkan diri kepadamu hingga kami bisa senantiasa dekat kepadamu. Ya Allah, ya Wahid, Engkau yang Maha Satu dan mempersatukan. Kami mohon perkuatkanlah persatuan di antara kami. Janganlah Engkau biarkan ada perpecahan di antara kami. Kami ingin kuat dalam persatuan itu, agar lebih bermanfaat untuk agama, negara, dan bangsa ini. Ya Allah, ya Ghafur, Engkau yang Maha Pengampun atas segala dosa. Ampunilah dosa kami, dosa orang tua kami, dosa para pemimpin kami, dosa para pejuangmu, dan dosa para pendahulu kami. Tempatkanlah kami dan mereka semua ini dalam lindungan rahmat dan ampunan. Ya Allah, ya Mujib, Engkau yang Maha mengabulkan doa, perkenankanlah doa dan permohonan kami. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Subhanaka rabbika rabbil izzati amma yasifun. Wassalamu alal mursalin walhamdulillahi rabbil alamin. Taqabbalallahu minkum minna wa minkum taqabbal ya karim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Alhamdulillah, semoga apa yang disampaikan dan kita aminkan, Allah Subhanahu wa taala senantiasa memberikan perlindungan kita terutama di saat-saat pandemi saat ini. Baik, Bapak Ibu hadirin yang masih setia menemani kita pada sore hari ini, kita akan coba dokumentasi. Untuk itu kami mohon kepada Bapak Ibu sekalian untuk memunculkan gambar terbaiknya, yaitu gambar diri Bapak Ibu sekalian. Kami mintakan kepada panitia untuk melakukan dokumentasi, boleh dihitung. Pada Ibu Fathia, kami persilakan, Bu.
Bu, hidupin dulu. Oke, siap ya. Silakan diaktifkan videonya. Pak Irham ya? Nah, itu. Mbak Anita.
Siapa Anita di sini?
Oke. Mr. Ekan.
Selesai ya Bu Patia fotonya?
Belum Pak, belum. Bentar.
Belum. Tunggu Pak
Masih ada
Erkan.
yang belum ya?
Ya, mohon diaba-abain Bu, biar
Ya, belum.
betul.
Oke, 1, 2, 3.
Lagi.
Bentar. Bentar. Belum. Slide 1 lagi. Oke, aktifkan ya.
Slide keberapa Bapak ini Patia?
Oh iya, mutu.
1, 2,
Dari
3.
HP soalnya datang ngeliat slide.
Oke. Salam Win ya, salam Win.
Ya, salamin.
Salam Win, yes.
Belum di 1, 2, 3.
Oke.
Sekali lagi, yang slide 1-nya. Belum. Satu lagi soalnya.
Belum ya?
Nah, tolong diaktifkan lagi ya. 1, 2, 3. Oke, habis.
Oke, thank you. Bye-bye.
Oke,
Ya, terima kasih Pak Dekan, terima kasih
Alhamdulillah.
semuanya. Panitia, terima
Saya
kasih
closing
semuanya.
sebentar, Bapak Ibu.
Kerja ikhlas, mudah-mudahan tahun depan lebih
Virus COVID masih gentayangan, jaga diri, tak perlu bepergian. Ingin terus merajut kebersamaan, mohon izin waktu telah usai. Saya yang bertugas mengucapkan, segenap panitia juga yang bertugas mengucapkan terima kasih atas perhatian, dan sampai berjumpa pada waktu yang kita tentukan kembali.
Mute kali.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih banyak Bapak.
Sukses panitia.
Terima kasih Bapak.
Terima kasih semua kepada presenter, pemakalah yang sukses hari ini. Semua panitia, semua partisipan, terima kasih. Mudah-mudahan tahun depan bisa luring.
Amin.
Amin.
Sertifikat nanti dikirim ya.
Bapak Ibu.
Kasih tahu.
Bapak Ibu, untuk sertifikat akan dikirim ke email masing-masing setelah mengisi daftar hadiran yang sudah di-share di kolom chat kita.
Pak Jauzi ini belum absen katanya. Pak Jauzi itu belum absen.
Jauzi belum absen. Tak kirim ini aja. Apa linknya link di grup.
Oke, alhamdulillah tepat waktu, selesai juga. Ya,
June 2.
Anda keluar tepuk tangannya tadi? Ngapa baru sekarang dikeluarkan? Tadi harusnya. Bapak Ibu Ketua Prodi, expo-nya sudah selesai. Mohon buku dan aksesorisnya. Silakan kembali ke fakultas. Dan tadi ada beberapa yang sudah nanya buku, harga buku. Tolong ditempel lain kali berapa harga buku tuh. Biar pacak dibeli wong. Sama harga produknya. Terima kasih. Mudah-mudahan expo seminar dan expo tahun depan bisa luring dan bisa rame. Bila perlu nanti kita coba dengan pemakalah-pemakalah internasional juga. Dengan membangun jejaring dari Bu Anita dan seterusnya. Terima kasih semuanya. Dan kita berberes-beres untuk buku kita masing-masing kepada semua